Question number 7 says to find any asymptotes and or holes. So the first thing you want to do is you want to factor your rational function here. The denominator is a trinomial. You want to look for things that multiply to -6 and add to 4, which would be 6 and -2. So you can factor this into x plus 6 times x minus 2. The denominator you can factor by taking out a GCF of x, and that would factor into x times x plus 6. And then you want to determine if the first thing you probably want to look for is if there are any holes. So you can determine if there's going to be a hole if there is a factor in the numerator and the denominator that would be the same, such that those would cancel out. So when that happens, when you graph it, you're going to end up with a hole in your function. So it's an undefined value, but it's not an asymptote. So in this case, you're going to have a hole when x equals -6. And then you need to determine the y value when that would happen. And so you're trying to see, you cannot actually ever get to -6, so you're going to use the idea of a limit. You would figure out what is the limit of that function as x goes towards -6. And if you were to do that with the original function, you can try and substitute in -6. It's going to give you an undefined value. And so the strategy that we use to simplify that is to factor first, cancel, and then try and find the limit of the new function, which at this point now we can substitute. So you would get -6 minus 2 over -6, which would simplify to be 4/3. So that tells us that we have a hole at -6 and 4/3. The next thing we wanted to do is to figure out if we have any asymptotes. So a vertical asymptote, the way that you look for a vertical asymptote is you look to see what's going to make your denominator equal to 0. Again, if it cancels out with a factor in the numerator, then that's going to give you a hole rather than a vertical asymptote. But a vertical asymptote is telling you the values where the function is undefined. So in this case, you're going to see what would make that equal to 0. Your vertical asymptote would be at x equals 0. And then you want to look for your horizontal asymptote. When you're looking for a horizontal asymptote, you're looking for the limit of the function as x goes towards infinity. So the easiest way to do that is to actually look back at the original form, and you're going to just look at your first two terms, and you have an x squared over x squared. Those would cancel and they would equal 1. And so you can look for the limit as x goes towards infinity of 1. Since there's no x in there, it's just going to be equal to 1. So that's going to tell you that your function is going to tend towards the line y equals 1 as you go towards infinity. If you were then asked to graph this function, you could graph your asymptotes, your hole. You could also graph your x and y intercepts and do a sign chart to determine what the function would look like. The other asymptote that could also exist is an oblique asymptote. An oblique asymptote will only happen if there's no horizontal asymptote. So if there's no horizontal asymptote, you want to look for an oblique asymptote. And to do that, you would do synthetic division with your function to find your oblique asymptote.